All right, let's take a look. Let's see what we came up with on the y equals 1 over x. This is going to be this is the starting point for this entire chapter. You know, we talked before about like parent functions and things like that. Like y equals x squared is the parent function of all quadratic functions, and then everything else works off of that. Y equals x is the parent function of all the linear functions. This is the parent function of all rational functions. Okay, this is where everything starts. And so what you should have ended up with, if you take a look, if you went through and like I said, the only way that you probably would have had any idea how to do this in general would be just plot some points. Pick some values, okay? Pick whatever you can for x. Is there anything, by the way, that I can't pick for x? Anything that x could not equal? Think about fractions. That's what we're dealing with. 0. Okay, remember you cannot divide by 0. So the one thing you couldn't have was x equals 0. Okay, because 1 divided by 0 is nothing. It's not an answer. It's undefined. Okay, so that's the one value that we can't have is x cannot equal 0. But if you plug in 1, you get an answer of 1. You can plot that point 1, 1. You plug in 2, you get an answer of 1/2. You can plot the point 2, 1/2. You plug in 3, you get 1/3. You plug in 4, you get 1/4. And what I'm hoping you're noticing is as you start plugging in those values for x, you get 1/3, 1/4, 1/5, 1/6, 1/7. We're getting closer and closer and closer to 0, which is kind of like that idea back in exponential functions again, where we talked about a horizontal asymptote. It's approaching 0. It will never actually get there, but it is approaching 0. So there actually is a horizontal asymptote right here at 0. Okay, which we'll talk about that when we get there and why that's the case. But those y values are approaching 0. Okay, if we plug in negative values, you get -1, -1/2, -1/3, -1/4. So same thing. Even when we go in the negative direction, even when we're over here, we're still approaching 0, but never going to actually reach it. Okay, so what the graph should actually look like is something along these lines. You should have had a graph that looks something like that. And then another part, there's actually 2 parts to the graph. Looks something along those lines. That's what the graph actually looks like. There's 2 separate parts to the graph. Okay? There's 2 separate parts to this graph. And if you take a look, like I had said, there is a horizontal asymptote here. I'm going to kind of make it bigger so that you can see it. And it turns out, remember we said x equals 0? X cannot equal 0 because we can't divide by 0. Turns out there's actually a vertical asymptote at x equals 0 as well. So there's both a horizontal and a vertical asymptote in this case. Okay, and so those are some of down below when I said, kind of discuss with what characteristics do you notice? Those are some of the characteristics that I want you to notice. Those are 2 of the key features we're going to talk about. Today specifically, we're going to look at 4 things, most of which we've already talked about in previous chapters. Number 1, we're going to look at how can I tell if there's a horizontal asymptote, and if there is, how do I know where it is? Number 2, we're going to add in this idea of vertical asymptotes, okay? And same thing, how do I go through and how do I figure out if there's a vertical asymptote and where it is? And then the other ones are just x and y-intercepts, just so we have some points that we can plot. Okay? So if we take a look, let's go down to the next part here. Here is the definition, kind of the basic definition of a rational function. Like I had said, a rational number, remember our numbers that you can turn into a fraction. So we're dealing with fractions is what we're dealing with. The only difference when we're talking about rational functions is basically you've got, notice I put it as p of x over q of x, where p and q are both polynomials. So you might have 3x plus 5 in the numerator and 7x minus 2 in the denominator. You're going to actually have functions in both numerator and denominator, or you could, I should say. Okay? A lot of times as we get going here, once after today, we're going to start looking at quadratic functions in the numerator and denominator. Sometimes you'll have cubic functions, okay? So but the idea is you've got a function in both the numerator and denominator, okay? And notice I had said q of x cannot equal 0. We kind of talked about that because you can't, one of the rules of fractions, you can't divide something into nothing, okay? So you cannot have the denominator equal to 0, which leads exactly to that question. Where did the asymptotes come from in the warm-up? We're going to look at the horizontal asymptote came from one place. The vertical asymptote, remember we said x can't equal 0? Well, our vertical asymptote right here is at x equals 0. That's basically a line saying, nope, can't have any values there. Not allowed. Okay? So the idea, that's where we're going to get into. Our vertical asymptotes are always going to come from where would the denominator equal 0? And then knowing you can't have that. Okay? And I mentioned this couple of things here. A graph will never cross a vertical asymptote, ever. Okay? It's kind of like an imaginary boundary line, if you will. It will never cross that line. It can get really close to it. It'll approach it, but it'll never cross it. It is possible that you could cross a horizontal asymptote. Okay? It does happen, not very often. And the idea, I'm going to use a horizontal asymptote is also called an end behavior asymptote. So as you move away from the two ends of the graph, it acts like a normal or normal asymptote. It won't cross. But kind of in the middle, it's possible that it could. Okay? Most of the time it's not going to, but it is possible. If it does, we call it a cross point. Okay? So just a little background information. Go to the green sheet that I gave you. This is going to be kind of your formula sheet for this graphing these functions, kind of this week, if you will. And I'll let you use this on the test again, like I did on the last test, having something. So here's kind of the process. Here's what we're going to take a look at. First thing I'm going to always have you do is we're going to find the horizontal asymptote. Okay, where is it located? Do I have one? Where is it? And basically what you're looking at is there's only 3 options. And really, we're going to narrow it down to 2 options, because option 3 we're not going to worry about this year. Okay, we're going to take the 3 and narrow it down to 2. So if you notice, in part A here, if you notice I say bottom heavy, what I'm looking at is the degree. What's the highest degree of each numerator and denominator? So bottom heavy in this case, what I mean by that is if the degree of the denominator is bigger than the degree of the numerator, then that's bottom heavy. It's a higher power on the bottom. Okay? Therefore, then your asymptote will be located at y equals 0. So if we go back to this warm-up for a second, notice that's where we were. We were at y equals 0. And the reason is, this is x to the first power. So the denominator of this function is first degree. The denominator, or the numerator, doesn't have any x's in it, so it's a 0 degree. So this one is that first thing that we were just talking about. It's bottom heavy, if you will. Okay? Higher degree on the bottom, which means y equals 0. And right there, like we had talked about, there's your horizontal asymptote right there. Okay? So it fits with option number 1. We're going to take a look at that. Option number 2 is if it's a tie. Let's say there's just an x on the top and an x on the bottom, or an x squared and an x squared, okay, or whatever. The degree in the numerator and denominator match up. They're the same. Then you're going to have an equation at y equals, basically you look at the coefficients of those degrees. Okay? Whatever the coefficients are is where the horizontal asymptote is going to be located. So it's either at y equals 0 or at y equals whatever those coefficients are. And we'll take a look. I've got some examples for you. Okay? The third option that we're not really going to worry about it, I put it on there just to kind of make you aware, is if the degree of the numerator, if it's top heavy, okay, higher degree on top than bottom, then there's what's called a slant asymptote. And we're not going to worry about that this year. We're not going to get into that. I just want you to know that there is something called a slant asymptote. If you get into, you'll get into that more so in depth into pre-calculus or something in the future. For now, I just want you to know that there is something called a slant asymptote that we'll get into. Okay? So really, it's 2 options. Either y equals 0 or y equals the fraction, the coefficients. So that's number 1. The vertical asymptotes. Okay, how do I know where the vertical asymptotes are located? It's exactly that. Those come from where, remember, we can't have a denominator equal to 0. So we figure out, well, where does the denominator equal 0? And that's where your vertical asymptotes are. Those are the values you cannot have. Okay? So that's we'll take a look at that. X and Y intercepts go right back to what we've talked about since chapter 1, okay, all the way back to the beginning of the year. X intercepts are always when Y equals 0. Y intercepts are always when X equals 0. Now, one thing to keep in mind, just as a quick heads up, when we talk about these X intercepts, we said that's when Y equals 0. I'm going to come back up to just our equation for a second. When does a fraction equal 0? In general. Just think about a fraction. When does a fraction equal 0? When what's true? We already said the denominator can't equal 0. We know that.
When the numerator is 0?
When the numerator is 0. If you take 0 divided by 2, 0. 0 divided by 5, 0. 0 divided by anything, you get 0. So a fraction equals 0 when the numerator equals 0. And that's why on number 3 here, if you notice, it says it comes from the zeros of p of x. Basically, it's saying when the numerator equals 0, that's when the fraction will equal 0. Okay? All right, and then if we go through, the last thing we're going to take a look at is domain and range. And basically, what we're looking at is it's always, you can plug anything you want in for x, except for where you've got a vertical asymptote, like we talked about on the warm-up. We couldn't plug in x equals 0, it wasn't allowed. And we'll talk tomorrow, we'll add in the idea that sometimes there's a hole in the graph, okay, kind of a missing point, if you will. We'll talk about that tomorrow. Okay? The range, all y values, the only y value you won't have is the possibility of wherever your horizontal asymptote. Okay? So if you take a look back real quickly at the warm-up, if we're talking domain and range, the domain of this graph, we've got every value of x here on our graph except x equals 0. And that's because that's where our vertical asymptote is. If we look at our range, this goes down forever, it goes up forever. The only y value that does not come into play is where our horizontal asymptote is at, y equals 0. That's the only y value that is excluded. Okay, so just a heads up. Let's do some examples here. Let's see what we have. So keep that green sheet handy, and let's go to the first example. And we'll kind of put this to work so you understand kind of how this stuff actually works. So first one, let's take a look at the horizontal asymptote, which means we need to compare degree. Okay, what do we have on this one? You see, do we have a higher degree on top, bottom, or are they equal? And remember when I say degree, we're looking at the highest power.
Bottom.
Yeah, why do you say bottom, Logan?
It's like if I plug in 1, it's higher.
Now, not necessarily a higher number on the bottom, higher degree. What is degree? Let's go back to that for a second. What does degree mean?
Is it like power?
Power.
They're the same.
They're the same, right. Those are both x to the first power. Okay? Those are both linear. That's a linear function over another linear function. Okay? So those are both x raised to the first power, which means this is in that first category, or second category. This is a tie. Okay? Which means now what we take a look at are the coefficients. Right there, the coefficients of those values of x. So my horizontal asymptote is going to be at y equals 3/4. Okay? 3 over 4. We just take a look at those coefficients is all we do. So if we go through, I'm going to graph that right away. If we go through and we graph that, let's say y equals 3/4 is approximately, let's call it right here. I'm just going to kind of make this up, or at least an approximate. Y equals 3/4. So there's that horizontal asymptote. Then we move to the vertical asymptote. Okay? And normally what you're going to hear me say is we want to go through and we want to factor normally in order to then get the vertical asymptotes. Okay? You want to try to factor this. Well, in this case, there's no factoring. I can't factor anything out. There is no factoring that we can do. Okay? But normally that would be the next step. Is you get into the problem and say, okay, do I have any greatest common factor I can pull out? Do I have, we're going to go back to difference of squares. Do I have, those types of things that we talked about a few chapters back? Okay? In this case, there's nothing I can do. So the vertical asymptote, you remember, occurs, you can't have 0 in the denominator, so we figure out, well, what value of x would make it 0 in the denominator? And then we exclude that from the graph. So if we take, I'll just do the work here. If we take the 4x plus 1, and I set that equal to 0, okay? And basically I'm going to say, let's set that equal to that it can't equal 0. And therefore, let's figure out what x equals so that I don't get 0. So if we solve this, subtract the 1 over, I'm just going to kind of put this over here. If we subtract the 1 and divide by 4, you'll find out that x cannot equal negative 1/4. And that is therefore where you've got a vertical asymptote, at negative 1/4. Let me stop for a second. Does it make sense? Do you understand why it cannot equal negative 1/4? The biggest idea, and we go back to it, the main idea of that is you can't divide by 0. Negative 1/4 is the value that if you plugged it into that equation would give you 0 in the denominator. Okay? Not allowed. So that's where that's coming from. So if we go through and let's put a vertical asymptote in here, let's call this approximately negative 1/4, or we'll do it right here. X equals negative 1/4. There are my vertical and horizontal asymptotes. And now I want to find a couple of decent points here, a couple of x-intercept, y-intercepts, just to kind of see what this graph looks like to help me sketch this a little bit. Remember, x-intercept is when y equals 0, and a fraction equals 0, like Mike had said, when the numerator equals 0. Okay? So all I have to worry about is I don't have to take the whole fraction and set it equal to 0. All I need to do is take the numerator and set it equal to 0. Because if I get 0 on the top of the fraction, we'll get that fraction will equal 0. It doesn't matter what the denominator is. So let's take 3x minus 4, and let's set it equal to 0. And now, once again, we solve. If you go through and add the 4 and then divide by 3, you end up with x equal to 4/3, which means you have the point then 4/3 comma 0. There's your x-intercept. That's where the graph is crossing the x-axis. Which means we'll approximate this again as well. Let's say we're approximately right here. There's my x-intercept. And my y-intercept is a little bit easier in the fact that it's always just when x equals 0, so you plug it in. Okay? Plug in 0 for x and see what you get for an answer. So if I plug 0 in the numerator, 3 times 0 is 0, minus 4, I get a negative 4 for the numerator. 4 times 0 is 0, plus 1 gives you 1. So you actually end up with negative 4 over 1 as your y-intercept. When x is 0, you end up with negative 4 as your y-intercept. Which means we'll just, again, kind of approximate this. We'll say we're down here someplace. And now we could, because that's not a lot of points necessarily, we could go through and add in some x, make an xy chart, create some other points. What I'm going to tell you is this. Generally on the graph, okay, when you go through and you take a look, notice how the two curves are in opposite corners, okay? That's exactly what you're going to be doing for the most part, okay? That always happens with rational functions, is you won't ever have two curves that are right next to each other. They're always going to be kind of diagonal from each other. So in this case, based on the data that I have here, I know that I'm going to have some curve down here because of those points. It's got to go through those x and y intercepts, which means the other curve has got to be up here. Okay, they're going to be in these two areas. So this first one we'll go through and kind of sketch in. There's what that'll look like. And if that's, like I said, if that's where one curve is located, then diagonal is where the other half of the graph is going to be. And there's approximately where the other part of the curve will be. These are the four main things I'm going to have you look at today. Okay? Horizontal asymptote, vertical asymptote, x-intercept, y-intercept. If, by the way, if we kind of quickly wrap this one up, if I were to talk about the domain of this function, all real numbers except what? What's the one value of x that we couldn't have? Was it? I thought you said it. Was it?
0.
No, it's not 0 on this one.
Negative 1/4.
Negative 1/4. The one value that I couldn't have is x equal to negative 1/4. That's where my vertical asymptote is. For my y values, I've got all real numbers except which y value? What's the only y value that's not included on this graph? It's the 3/4 right here, okay? So there's only one x value, there's only one y value not included in the domain or range. Can't equal negative 1/4, that's why there's a vertical asymptote. Y can't equal 3/4, that's why there's a horizontal asymptote. Kind of signifying, hey, you can't have these values. Okay? Any questions on this? Anything as I was going through this that just completely went past you and did not make sense at all that we want to clear up before we move on? All right, let's take a look. Let's take a look at example number 2. Let's do another one of these ones together. So first question, horizontal asymptote, and again, use your green sheet to help you, kind of work your way through the green sheet. Keep talking about that. On example number 2, top heavy, bottom heavy, or is it a tie based on the degree? For the horizontal asymptote. Top heavy, bottom heavy, or tie on this one? He's copying me over there. He said the exact same thing I just said. See? He's doing pre-calc. I'm doing algebra 2. It's coming back. What do we think? Abby, what do you think? Top heavy, bottom heavy, or tie? Yeah. Again, this is just like the previous one. X to the first power on top, x to the first power on bottom. Okay? So these are both linear functions, and therefore we have a horizontal asymptote at the coefficients, okay, which coefficient on the top, there's no number written, but technically remember there's a 1 sitting right there. So we have a horizontal asymptote at y equals 1/3. Okay, the coefficients of those highest degree powers. Okay, so we can put that in here. Let's approximate that. Call that y equals 1/3. How do I go about finding the vertical asymptote? I always find vertical asymptotes where? Or how? Remember the one rule, basically the one rule for fractions, you can't have 0 in the denominator. That's always where vertical asymptotes come from. Okay? So we're going to take the denominator and set it equal to 0 and figure out what value of x can I not have. And that's where you've got a vertical asymptote. So if we take 3x plus 2 and we set it equal to 0, okay, can't have 3x plus 2 can't equal 0. That's why there's a vertical asymptote. So we then do the solving, and we end up at x equals negative 2/3 is where you would have a vertical asymptote. Okay. Y equals 1/3 horizontal, x equals negative 2/3 is your your vertical. And again, the reasoning, if I were to take this negative 2/3 and plug it into this equation, you would get 0 in the denominator. And you can't have that. That's the one value you can't have in the denominator. Can't divide by 0. So x equals negative 2/3. Let's put that in here. Let's call that, there's my approximate vertical asymptote. And now we kind of find the x and y intercepts so that we can kind of figure out where the graph is going to go, where the curve is going to be located. So x-intercept, remember when y equals 0 and a fraction equals 0, where the numerator equals 0. Okay? So we take the numerator, x minus 5, we set it equal to 0, and figure out what x is. All you got to do is add the 5 over, and therefore we have the point 5, 0. Okay. X-intercept at 5, 0. So we're somewhere, let's say, over here. And finally, y-intercept is always when x equals 0. So we take x and make them equal to 0 and get an answer. In the numerator, we get negative 5. In the denominator, I get a positive 2. And therefore, we end up with 0, comma, negative 5 halves. And all that's coming from is taking 0 and plugging it in to the fraction. Plug in 0 for both x's, and then you just get an answer. You get negative 5 on the top, you get 2 on the bottom. So 0, negative 5 halves, we'll say that's somewhere about right here. And once again, now we have enough information to be able to kind of sketch this graph. We know where the curves will be located based on the asymptotes and the points. Curve number 1 is going to once again kind of look something along those lines. And if that's where the first curve is, the second curve is always diagonal. Okay? And therefore, curve number 2 will be somewhere in that vicinity. How are we doing? Making a little bit more sense? Getting the idea? Remember, today's day 1. Today, the whole point of today is to get you the idea of what these look like in general. Start understanding how you find horizontal and vertical asymptotes, but X-intercepts, Y-intercepts. But the idea is, it's the start. Okay, today's the start of everything. Let me give you the worksheet real quickly, and then I don't know why I have this example on it twice, but let me give you the worksheet. We'll go from there. Mr. Scholler, what's up?
Good morning. How are you?
Good. How about yourself?
Monday.
Yes,
Fantastic Monday.
It is. See that every day.
Yeah.
It's good too. Go right to number 8. We're going to do number 8 together as kind of our final example here. It's a little different than everything else we've done. All right, so if you take a look at problem number 8 on the worksheet that I just handed out, and this is your assignment. We're going to actually do number 8 together, though. Just because, like I said, it's a little bit different than what we've done so far. There's a little bit more to it. Let's start with this. Just work our way through this process, though. Same thing again. So number 1, horizontal asymptote. Top heavy, bottom heavy, or equal? Bottom heavy this time, right? Which means where's the horizontal asymptote?
0.
At y equals 0. Anytime it's bottom heavy, you've got second power in the bottom and 0 in the numerator. So therefore, y equals 0. We know we have a horizontal asymptote right here on the x-axis. Y equals 0. Okay, so now here's where this gets a little bit messier. Vertical asymptote. We got to figure out where does the denominator equal 0, because that's what we can't have. And now here's where the factoring comes into play, like I was talking about. We're going to take that quadratic, set it equal to 0, and you don't have to factor, although we're going to be doing a lot of factoring in this chapter, so it's probably a better method to factor. So let's kind of go down below here, the graph. Let's take our 3x squared plus 6x minus 9, equal to 0. And now we're trying to figure out what values of x would make the denominator equal to 0. What can I not have? So, one thing that I'm going to do right away, notice that there's 3 in all of those. I'm going to just divide the 3 out completely and make this easier. Okay, I'm going to divide everything by 3. So this becomes x squared plus 2x minus 3 equal to 0. Part of the reason that 3 can go away is because I'm also dividing the right-hand side by 3 as well. I'm dividing both sides of the equation. And 0 divided by 3 is still 0. So now we factor. And that makes this factoring a lot easier. We've got x times x. It's always what multiplies to give you the first term. And then the last part, what always multiplies to give you the last term. So in that case, it has to be 3 and 1. And since it's a negative 3, we know we're going to have one positive and one negative. And since we're looking at the middle term here, we need those two numbers to add to the middle term and multiply to the last one. So in this case, we need a positive 3 and a negative 1. There's your factoring. Last step then is, once you have factored, then you're going back to the zero product property, meaning now we got to solve. If either one of those factors equals 0, the whole thing will, which means this would be x equal to negative 3. And this one, you would have x equal to 1. So you actually have two different values that would make the denominator of this problem equal to 0, which means you actually have two vertical asymptotes. And it's not going to happen a lot, but I wanted you to see it at least. X equals negative 3 and x equals positive 1. You have two vertical asymptotes here. So if we put that in, call this one x equals 1. Let's call that one x equals negative 3. And so now we've actually split the graph into kind of 6 parts. You got 6 options. You got this kind of upper left, lower left, the middle top and bottom, and then the right top and bottom. Okay, so you kind of have six parts to this graph that we'll take a look at. All right, x-intercept. When y equals 0, what do you think? Remember we said it's always when the numerator equals 0. When's the numerator going to equal 0? It's not going to. It's always going to equal 1. Therefore, none. There is no x-intercept on this one. It will not. This graph is not going to cross the x-axis, partially because there's a horizontal asymptote there. Okay? And then the y-intercept, remember, is when x equals 0. So all we have to do is plug in 0 and get an answer. The nice part is when I plug in 0 here, that equals 0. When I plug in 0 there, that equals 0. So the denominator actually equals negative 9, and therefore your answer is negative 1/9. When I plug in 0, you get negative 1/9 as your y-intercept. So we're approximately, let's say, about right here. And now at this point, you're thinking, all right, I've got 1 point, I've got some asymptotes, things along those lines. Okay, and so the last thing that I'm going to have you take a look at is, and I gave you the answer key on this one, but if there's some that don't have answer keys, I'm going to show you just a very quick way that you can check. And let me let me repeat that. Check your answers, okay? Because if you do it this way, by the time you're not going to be able to use this on the test, okay? You're going to need to work your way through the process. And what I'm getting at is Desmos. You can always plug this in and kind of take a look at the graph. So if you notice, if we do 1 divided by 3x squared, what was it? It was plus 6x, right? And then minus 9. There's your graph right there. There's what it looks like. Notice how, again, they alternate. You can kind of see that here's your vertical asymptote at x equals 1 that we talked about. Here's your other vertical asymptote at x equals negative 3 that we were talking about. Here's your horizontal asymptote at 0. Okay, whoops. And so you can always kind of go through and check your answers that way. The graph, like I said, basically will look something like this. Now, like I said, I gave you the answers on this sheet. It's the last page. So you can go through and work your way through it. I do want to see the work. Okay? Like I said, I want to see the work. I want to see where are the vertical asymptotes coming from? Where are the horizontal asymptotes coming from? I want you to show me the work that goes with it. Okay? But otherwise, that worksheet is your first assignment for this chapter. Okay? Just working through and graphing that. We're only going to add one thing in tomorrow as we move forward. The idea of holes in the graph and things along those lines. Okay? So work on this. Come with some questions tomorrow. We'll see where you're at.